Hi, I'm Ben Solomon. I am about to present my opinion based on statistical analysis of the COVID vaccine and how the modeling shows what's really happening. Let me share the screen. Okay. Um, this is a statistics-based opinion. I have 40 years of working with data in many different industries, finance, operations, credit risk, physics, and I have a master's in operations research from a British Ivy League, University of Lancaster, and a master's in banking and finance from the University College Dublin. That program is the oldest graduate finance program in Europe. So what I've got to say, I say after having done a lot of thinking and I have a solid foundation in the methods that I have used and developed to figure out what's going on. Okay. If you read the mass media, if you listen to what the FDA is saying or the CDC is saying, it's all great, nice, rosy pictures. They said vaccines are safe for both adults and children. If there are vaccine-related deaths, that means deaths from vaccines, not post-vaccine infection deaths. Those are two different things. It's insignificant, and these synthetic vaccines are better than natural immunity. We'll address all of these. I've compiled reports, information, publications that reputable scientists have stated to explain what's going on. Since the mass media, FDA and CDC are saying rosy, glowing things about how COVID-19 lockdown is being handled and how the vaccines are so good for us, I don't need to repeat that. I will focus on the downside risk. That's basically been my work, my expertise, 10 years on looking at how downside risk behaves from a statistic perspective. So one of the things that I was informed, and I've pulled off the information of the CDC, the original definition of vaccine is it's a suspension of live inactivated or fractions of organisms. And the purpose is to stimulate the body's, the host immune system to prevent infectious disease and subsequent outcomes. The new definition that was slightly before November 13th, this new definition came about. It's now a preparation that is used to stimulate the body's immune response against a disease. So this is a diagram. I picked it off. I forgot where I picked it up. I usually note down the sources of my images. So you have the mRNA vaccine, the preparation, and it uses the human cell, body cell, to convert to generate spike proteins, and then those spike proteins come in contact with the human white blood cells, and the human white blood cells produce antibodies, and you generate an immune response. Whereas DNA-based vaccines interact directly. So this step 1 to 4 does not exist for DNA-based vaccines. So if this portion of the steps 5 and 6 are working correctly, any adverse effects due to mRNA vaccines occur between step 2 and 4. And I use articles that have been published by major news outlets like the Wall Street Journal. I find that the Wall Street Journal is a lot more balanced than most other news services. But they still make statements which I cringe. For example, this is taken from rising COVID-19 breakthrough cases hinder efforts to control viruses, November 6, 2021, Wall Street Journal. The statement that causes me to cringe is this: the virus can still, in some cases, infect the body and replicate, causing illnesses before the immune response can tackle it. First, for a infection to happen, the virus must infect the body. It's not in some cases. Second, if the virus does not replicate, there's no issue. It has to replicate until a certain viral load before the immune system can detect the virus and respond to it. You see, this thing is pure thermodynamics. It's got nothing to do with medicine. It's basically fluid flow. You have a blood vessel, you have a white blood cell in one portion, and you have the virus in front of it, both flowing together. As long as they are flowing together at the same velocity, in the same direction, they will never meet. The immune system will never know that there's a virus in the bloodstream. So the thermodynamics comes into the picture when the arteries distribute out, and let's say this is the artery, and these are the smaller arteries that branch out into the body. When this happens, the blood experiences some turbulence. Okay, and so when there's that turbulence and you have the mixing, and the white blood cells can come in contact with the virus particles. The opposite is when you have tributaries. The smaller veins come in and join the bigger vein, and so all these blood that is in the smaller veins come in have turbulence and mix around, and you have collision of white blood cells with virus particles. There's more turbulence in the vein than there is in the arteries. And so the ability, just from a purely thermodynamics point of view, the ability of the body, the immune system to detect the virus is primarily in the veins. And so you could say that nature's designed the lymph system to be connected to the veins, not the arteries, not just because of the pressure. That's also another thermodynamic problem. And so that turbulence is so important for detection of viruses. So this statement sounds right, but it's misleading. Okay, now the second point is that models can be very, very wrong. They sound like, they look like they're doing the right things. For example, the reproduction model, I believe it was Ferguson and Imperial College, and these are very prestigious institutions with very credible professors who are coming up with these sort of things. This was taken from the Cato Institute. They had Alan Reynolds had written about how the reproduction model had claimed that there will be 2.2 million dead in about 2 months. This was April 2020. And so I looked up. It's basically, it's called the reproduction model with R naught. And so I looked up what exactly is this reproduction model. And the Institute of Health Metrics Evaluation, IHME at Washington University, has a pretty good set of documentation on this reproduction model. And then I realized, because I have 40 years of working with data in many different fields, I realized that the key thing when you're doing statistical analysis is understanding the context of the problem you're examining. So when you have a reproduction model, it's also used in evolution, it's also used in medical studies. When you have a reproduction model which says 22.2 million dead in 2 months, you have to understand this is a major warning, and the 2.2 million dead did not materialize. This is a major warning. It's a red flag about the model, that this model, this type of models that academia uses, prestigious universities, serious, brilliant scientists and researchers are using this model, and it hasn't occurred to them that this is a red flag. There's something seriously wrong with this model. So, and I read quite a bit of the documentation. I would say that the IHME's reproduction model documentation is 100 times better than the Federal Reserve's documentation of bank stress tests, because that's my background. And I compared it to, hey, the Federal Reserve, if you look at the bank stress test model, there's only 2 mentions of loss given default, LGD, in the entire 150 pages. But the model is supposed to be about LGD, loss given default. Here, in the IHME's documentation, they actually tell you, hey, this is what the model is. These are what are the things we're doing. This is how we generate the data to test. That method of generating the data to test is faulty. If you are a professor who is working in one field and you're using the same technique again and again and again for 20, 30, 40 years, you will not understand when statistical techniques break down. If you are somebody like me who has used many different techniques over 40 years in many different situations, in many different fields, you will understand that certain techniques, even though the theory behind the techniques say that it works, it actually does not. For example, in regression, you have a statistic, a parameter, which is called the F ratio. And the higher the F ratio, the better the fit of the model to the data. What I found is that when you start getting F ratios, usually F ratios about 20 something, 10, 20, 90. But when you start getting F ratios like 10,000 and 60,000, which I have seen, and you go back and investigate, most people, they don't. you go back and investigate, you find regression techniques get very high R squares and F ratios when the technique breaks down. There's something in the data that no longer allows that regression to be a valid technique in analyzing the data. And you get phenomenally high R squared and F ratios. That is the problem with reproduction. So I built my own statistical model. I used the first 42 days of the alpha variant of COVID-19, basically from February to somewhere in March. And there are three parts to this model. This your empirical data, you have the stochastic model, you have the structure model, and you have the latency model. When you combine the three together, the three cooperate with each other to make sure everything works together. If they don't cooperate with each other, you won't get sensible results. This is the only way you get sensible results. And it's on the first 42 days of the alpha variant. The data had not been politicized, the data had not been massaged, there was no medical intervention. You see the raw behavior of the virus. And this, the model is, if you see one person infected, this is the infection acquisition rate. If you see one person infected today, what is the number of people who will be infected tomorrow for every one person? It's 1.16. That means for every one person that's infected today in an infectious disease spread like COVID, tomorrow you will have 16% more people infected. This is the first 42 days. That these rates will change as the infectious disease spreads, and then it will drop when the disease spread reduces. The relative recovery rate is 2.34. And that means for every one person who recovered from the disease, you expect 1.34 additional people to recover from the disease the next day. And for every relative mortality rates, for every one person that died today, you expect 23% people, or an additional 23% people to die tomorrow. So these numbers tell you how the disease is progressing. If the relative recovery rate is much greater than the infection acquisition rate due to transmission of the disease due to infectiousness, then you know the population will overcome the disease, the infectious disease spread, and it'll eventually self-terminate, because everybody who has recovered has built a natural immunity and are resistant to the disease. But the important thing, see, when the raw data in February suggested there were about 35 people infected when CDC took note. The modeling shows, to get really good fit with the data, to get these numbers, modeling shows that there were almost 2,000 people already infected at the beginning of February 2020. Think about that. The disease was in the country many, many months, because if you look at 1.16 and to get to almost 2,000, the disease was in the population many, many months before anybody took notice. Okay, and this is the, I call it the disease life cycle. As far as I know, this is the first in medical history. You have the three probability distributions: the infectiousness profile, the recovery profile, and the mortality profile. So when you assemble, when the model generates these three profiles, and it gives a very good fit for the data. So one of the things it shows that there are 6 triggers in the disease profile. On day 1, first trigger, when the person gets infected, because if the person is not infected, the person is not infectious. It takes 8 days, trigger 2. It takes 8 days for the body to recognize that it has been infected. The viral load is sufficiently large for the body to recognize. Remember, this is a thermodynamics problem. If the virus is floating around and the white blood cells are floating around and they never meet, the white blood cell will never know that there's a virus. So you have to build up, the virus has to build up its numbers to the point where at least one virus must collide with at least one white blood cell before, that's very crudely putting it, before the body, the immune system can respond. And then on the third trigger is that on day 12, so the virus is in your body for 8 days before the body recognizes the pathogens present, and it's in the virus is still multiplying, and the immune system is triggered on day 12. So we have 2 probability distributions. One is the infectiousness of the disease as an infectious disease spread. It's at the peak is 18% probability of a person being infected is 18%. And the body starts to be infectious from day 8 all the way to day 25. Okay, and that's from day 1 to day 11 is basically the incubation period. The body, and then the immune system kicks in on day 12, and the immune system starts fighting back, and the body starts recovering from the infectious disease. And on day 23, you get the first mortality. This is based on 1,300 deaths out of 338,000 cases. So it's a pretty solid analysis. On day 33, you get your first death. So when a person dies from COVID-19, you know that they got the infected 23 days earlier. That's when they got infected. And this is the reason why the COVID tracking, all the software tracking to do the COVID tracking failed. Because it happened much earlier. The initial the infection process started anywhere from 23 to 8 days earlier. And you see that, so you can classify the disease by days. Day 1 to 11 is the incubation period. Day 12 to 22 is mildly to seriously ill. And day 23 to 30 is critically ill, because from day 23 to day 30, the probability of death starts. And why I say day 30, because by day 30, the immune system is overwhelmed. Day 25, the body is no longer infectious. At day 33, the immune system is overwhelmed and it has given up. But the body can still survive. It can survive, but it is now terminally ill. So from day 32 to day 86, the body is terminally ill, and this is where you really need some kind of intervention if you want to save lives. The thing that really puzzled me is that why is, if infectiousness is a virus property and not a host property, why is infectiousness early in the disease and not later in the disease? For example, the body starts recovering here, and then the body gives up on day 31. So why not let the virus has recognized that the body is terminal, and why not get out of the body and go infect somebody else? Why is it late in the why is infectiousness early in the disease life cycle? And the only logical solution I could think of was that infectiousness is the property of the host. Evolution requires the best genes to propagate. And part of that is to transfer that information about the virus to its other members of the community. And there's an article which says that body is always not breathing, but always giving off smells. For example, dogs can detect cancer patients, can smell whether a patient has cancer, and so forth. And so if you eat too much of a certain food, you will smell a little bit like that particular food. And so this is a very similar mechanism. When the virus attacks the body becomes infectious because the host is communicating to other members of its community, hey, there is this problem, figure out how to solve it, and we will we'll get better genes, better immune system, get a healthier population. So from that, you can determine, from the statistics point of view, you can determine 6 different treatment types. Vaccination is before you get infected. Converting, because you have an infectiousness profile, another treatment would be to suppress the infectiousness of the disease. A third type of treatment is to recognize the pathogen. That means you shift this mode, this probability distribution, you shift it to the left. Drug treatments that cause the recovery to speed up, probably health supplements, vitamins, whatever you call it. Maybe there are drugs that are out there that can, over-the-counter drugs that can help improve the immune health of the body so that it can fight better. And treatment 4 is basically accelerate the recovery by skewing this right tail, moving it to the left, so it becomes a steeper, shorter, and it's not 30 days. It's 30 days, but this whole mode, this probability distribution skews that way, so that more people recover earlier rather than at a peak of about 20 to 23 days. And treatment 5 is you take this right tail and you pull it out. Okay, basically you are giving the immune system, improving the quality of the, enhancing the quality of the weakened immune system to strengthen it so that it can, it has more time to handle the disease. Treatment 6 is we try to shift this mortality profile, shift it all the way to the right, so that the probability of death doesn't start at day 23. Let's say it starts at day 60. That's the sort of things. That's a strategies from a statistical point of view. These are strategies that could be affected by treatments, whether it's drug or non-drug, supplement treatments to enhance the host population. So now we have this model, we can now characterize the disease. We can talk about, oh, this report said this, okay, it follows, this is why it shows up in the disease life cycle. Okay, now this is from the Lancet. It's this report, and this guy, I forget his name, but I believe it was episode 24. He talked a lot about this particular paper, and so I've used this as a reference. He said that 46% of the patients are asymptomatic. That means, what that means is that they are asymptomatic, and therefore they have recovered from the disease because they're still alive, and therefore about half the population has already developed natural immunity, 50%. Very important to remember that. So what that means, okay, when we say asymptomatic, we know that up to day 12, before the immune system kicks in, the disease is asymptomatic. You don't have any symptoms because the virus is still building up its viral load. It hasn't reached the point where the body says, hey, we have a problem. Okay, so infectiousness occurs between day 12 and day 31. And for both asymptomatic and symptomatic patients. So we have to be careful when we do scientific testing and claim that a vaccine is so effective if we do not check whether the vaccine that's given to us to a particular member of the population, whether they are unvaccinated but recovered from the disease, or they are unvaccinated and haven't had the disease, because those two populations are different. From a statistics point of view, those two populations different. The unvaccinated, not recovered, does not have antibodies. The unvaccinated, not recovered, the unvaccinated recovered has the full complement of antibodies required to protect the body, the host, from future attacks. So when you take that into account and you say you vaccinate people and you do not, if you don't take that into account and you say vaccinate people, of course, 50% of the population that you vaccinated will seem effective because they already have the immunity. It just looks like the vaccines are effective. So not taking that into account will compromise vaccine effectiveness test. Okay, now, there's a lot of debate about, there's a lot of arguments I shouldn't say debate, because what we see now in this country, it's not arguments. You better do that, or you're a sick person, or I am not going to do that because you are threatening to poison me. That is how the debate is being handled in this country today. We have to get away from that. The infection duration, if a if a person is unvaccinated, the infection duration is infectiousness lasts up to, it was 25 days that I said. Okay, so if you take this graph, if you take this bottom square and explode it, you say that the vaccinated infection duration is from day 0 to let's say day 12, day 15. Okay, so the person has been vaccinated and nothing happens because there's no virus to fight. And then the virus gets into an environment, the person gets into an environment where the virus gets into his nostrils and infects the person, and the virus starts replicating. So the body, what vaccines do, this is from a statistics point of view, what vaccines do is they shift this green distribution to the left, because the body doesn't require that 3 days, from 3 to 4 days from here to here, from recognizing that the pathogen is in there in day 8, because it already recognizes it, and the immune system to activate in day 12. So this whole these two probability distributions have been shifted left, so it recognizes the body can kick in faster and deal with that infection. So the transmission period is much the vaccine, because the vaccine is present, assuming it's a working vaccine, the body recognizes what's going on, and these two distributions shift to the right. So if they shift to the right enough, the body, the immune system kicks in and destroys the virus before the body can become infectious, or the immune system kicks in soon after the body has become infectious, but it terminates the period, the duration of how long the body is infectious. It was 25 days. Now it drops to maybe, let's say, 12 days. And so because the infectious period is very, very much shorter, we find that the infection acquisition rate is no more 1.16, it may be 1.0001. And that's how vaccines, proper, correctly working vaccines, terminate the infection, the disease spread. Okay. This report, also, this was published in the Wall Street Journal by its very reputable universities, very prestigious professors and very prestigious universities. They wrote this report. And basically what they said was vaccinated and unvaccinated, they are equally likely to pass the virus on to someone else. Why? Because infectiousness is a host response. And if you go back to the previous slide, so this probability distribution, this infectiousness distribution, is also moved to the left, just as the immune system's recovery probability distributions move to the left. So what their findings is that whether you're vaccinated or unvaccinated, you are equally likely to pass the virus on to someone else. Maybe maybe at not the same rate, not 1.16, it may be 1.01, but you still can do it. And so I talked about the time lag. And so, so when there's a time lag, you see, this is the first person gets the infection. The infectious period is between 8 to 25 days for both asymptomatic and symptomatic. And then in the study, they looked at the receiving vaccinated person 5 to 6 months later. And you have that same 8 to 12 days, but what's happening is that in infectious probability distribution now responds to as it gets transferred into the next person as an immune response probability distribution, the recovery. So when you hear news stories that, hey, I went to dinner last night and today I got COVID, that's a false statement. You may have gone to dinner at a party last night and you may have figured out you got COVID, you have COVID, but that acquisition of COVID virus happened at least 8 days ago. That's why COVID tracking failed. Okay, the mortality. Mortality is this probability distribution. It's from 23 days to 86 days without medical intervention. So when a person dies from the infection, you know that he got it at least 22 days earlier. He got it at this point, 22 days earlier. If he may have died here, so it was at least may have got it much earlier. Like if he died at this point, he got it 3 months ago. 3 months ago. And you know that the immune system kicked in at least 11 days earlier. And his immune system was not healthy 11 days ago and continues not to be healthy. So you can make some assessment of whether the drug was effective or insufficient based on how late in the disease life cycle that the drug, or how late in the disease life cycle that the person died from the disease. So the other concept is the viral load, and I've talked a little bit about this, is the amount of viral particles per milliliter of blood. And it basically, it reflects the disease progression. And you can convert it, once you have these graphs, you can convert it into the number of days that the person has had the infection. And so when the viral load is low, is early stage of the infection, and when the viral stage is low, it could be also in the late recovery stage. But when the viral load is high, you're probably in this area, in this region, which means that there is an excessive amount of viruses that the body is starting to fight back, and it has not fully conquered the disease, so you have a very high viral load. So when people are using viral loads to deliberately, there's a study in UK where they deliberately infected people with the COVID-19 virus to monitor and track the disease progression. But the question now is, what is the viral load they use? It's not stated. What's a low viral load, then the disease progression will take a much longer time. If it's a high viral load, the disease progression will be much sooner. So all that has to be recorded. Then there's this UC Davis report paper that said that there's a wide variations in the viral load, both for vaccinated and unvaccinated, and also between asymptomatic and symptomatic groups, but not between them. So basically what they're saying, what they have found, and this model confirms it, is that the variation of the viral load from day 0 to day, let's say, approximately end of the recovery, which is around day 30, 31, I think. So the variation in there's variation in the viral load in this time frame, that 1 month time frame, which is understood because the virus is replicating, increases, and then as the immune system attacks and overwhelms the disease, it comes down. So and for the unvaccinated, it is the same. So there may be a slight shifting in the distribution due to whether the person is vaccinated or unvaccinated, but the variance in the viral load is there. It's a property of the disease. It's a property of the immune system doing everything it can to protect the body. And they found that the average is basically the same. So this model explains that. So how good is the science? Albert Malone, he is the person who invented the mRNA technology, which the mRNA vaccines are based on. And he has clearly stated that natural immunity produces 50 different viral proteins. Synthetic immunity, like the mRNA vaccines produce only one protein. That's why I would say, looking at this kind of data, I would say the mRNA vaccines, the synthetic vaccines, are actually partial vaccines. They are not full vaccines because they only produce one of the 50 proteins required for full immunity. And then there's this other problem of leaky vaccines. Some vaccines, and these two guys did the research in dynamic research in epidemics as a paper. They did it on chickens, and they showed that some vaccines are leaky, and that means the disease looks like it's under control, but it's not. Okay, the household study, this is the paper that Wall Street Journal talked a lot about, did a good article on it. It's basically based on that paper that Wall Street Journal wrote up, is about symptomatic COVID-19. When a person with symptoms shares a home with somebody else. It's one of the better reports I've read, one of the better papers I've heard about. And that's why I chose this for this presentation. But I will show that there are still problems with this paper. It's written by a prestigious group of researchers and professors, and it's coming out of prestigious institution. That's why the Wall Street Journal picked it. Okay, so this is the breakthrough deaths. That means the academic and the pharmaceutical industry have, or maybe it was the FDA or CDC, they decided to call infections, post-vaccination infections, as breakthrough. And this is the breakthrough deaths for 4 weeks in terms of per 100,000 in fully vaccinated people in the UK, in England. And they counted those deaths within 60 days. The weakness in this study is that they don't tell you asymptomatic deaths. They don't tell you recovered and vaccinated, what are the deaths like. They don't tell you what is the background deaths. In 2019, the background, all deaths in the UK was about 900 per 100,000. And the second problem is because of the 60 days, the modeling shows that deaths can occur up to day 86, day 92 if you consider the first 8 days as well. And so when you cut off the death rates at day 60, you are actually reducing the deaths due to COVID reinfections. And so you're underestimating the deaths. Okay, so these people, this research institution, you can go read up the paper and find out who the professors were and who the research institution was. But their COVID death models between was from data between January 2nd, 24th, and the deaths, and their model, even though the study is based on January 2nd to September 24th, their model said that unvaccinated deaths were 849, not actual deaths, but the model deaths. And fully vaccinated people was 26.2, not actual deaths, but model deaths for fully vaccinated. So the model, you have to be very, very careful when you read this paper. The model shows that the death rates among unvaccinated people is 32 times greater than for vaccinated people. Then you ask, but natural immunity has 50 times more proteins, 50 times more sophisticated than synthetic mRNA vaccines. How does that make sense? It's actually upside down. Okay, so the only conclusion is that the COVID model deaths is completely wrong, because COVID model says 849. All of UK, all of UK is only 900 per 100,000. And then if you look at the England and Wales COVID deaths as published in this by the government of UK, it's 10 times smaller. Look at this. COVID deaths, England is 64 per 100,000. Wales is 89 per 100,000. And these are the deaths per 100,000 by in the year as of September 21, September 2020, September 2019. And they are about 800 plus. And the model says it's all of them are dead due to COVID-19. No, the model is off by 10 times. This is the same problem that happened in April 2020 when I believe it was Ferguson from Imperial College. He said 2.2 million dead in 2 months. Here, from what I understand, they're using the same model. The red flag hasn't gone up. They're using the same model. And they're now saying that death rate is 10 times. The model death rate is 10 times. When you compare it with the actual death rates, don't these scientists verify their models with real world data? I mean, What's wrong with these people? And this is from the VAS, which is the reporting systems for vaccines. Adverse deaths. You're supposed to report this um, information on VAS. And there are you reach a point where you don't know what to believe. There are people that saying that, hey, the VAS data is being cleaned up so that so that it looks like the deaths are not as serious as they are. Or then you have the other side, CDC, denying that that's happening. So because of the mass media, how the mass media has treated it, even when you read a report, you have to look at it 10 times and pick away at it to see whether the study was done really correctly or not. And so far, we have seen the studies have not been done correctly. They are biased. According to this is the data, this is the number of deaths per day since the vaccination. This is vaccination deaths, not post-vaccination infection deaths. This is vaccination deaths. It's 5 times greater than all the other vaccines combined together. So when you have statistics, you always have to ask yourself, compared to what? See, the reproduction model gets these outrageous numbers because the people doing the research do not ask the simple question, compared to what? And so you see that the vaccine deaths per million doses is 19.5 for COVID-19. For all other vaccines, it's less than 4.0, except for measles and mumps, which I'm told is not a big issue because there are very few measles and mumps vaccines. So the reported COVID vaccine deaths, assuming all deaths are reported, assuming that the data has not been cleaned up, massaged. The reason why I put it as 8 days is because the immune system, when we looked at the model earlier, the immune system has not kicked in until day 8. 41% of the deaths happen before the immune system kicks in, before the body recognizes that there's a virus problem. And there's a lot more data in the VAS. There's this VAS analysis.info. They publish a standard set of results, which is basically straightforward SQL queries, from what I understand. Okay, and so this is all data is basically US and other countries that people input the data, and this is the US data. You can see that the number of deaths, it's this. For the US, we know that there were 4 million doses that were affected with this data. So you have about 644,000 adverse reactions between December 2020 and present. That is November 21. And for all other vaccines, to get to this number, to an adverse reaction number that's similar to this, they had to go back to 1990 and compile the list of all the data from 1990 to 2021. And you can see that the number of deaths from COVID-19 is 1.3% of adverse reactions. And for non-COVID vaccines, it's 0.7% for adverse reaction. So the COVID-19 vaccines are twice as deadly. That's one way of looking at it. But you see that there's something that's different. most vaccines have twice the number of emergency room visits compared to COVID-19 vaccines. So that's 12.5% versus 27%. So I'm wondering what's going on here. It could be about the severity of the event. It is symptomatically not as severe for COVID-19, but it results in a larger death rate than for other vaccines where it is symptomatically more severe. So if you look in terms of the millions of doses administered, it's like 1 in 6 people who are vaccinated have an adverse reaction, assuming 1 dose per person. And that COVID vaccine death rate is twice the non-COVID vaccine death rates. There is more data that shows by adverse reaction type, by symptoms, it's a lot more serious. It can be up to, depending on the symptoms, the symptoms description, and the FDA has a list of all the valid symptoms. It can be 1,000 plus more symptoms for a specific symptom than a non-COVID vaccine in that symptom category. And go look up the VAS analysis.info and you can see all the data you want to see. And then let's go back to this report. I like this Wall Street Journal write-up of this report because this is a really reputable newspaper, mass media outlet. They pick and choose. Because I read it because I find them very balanced, and they a lot of times present both sides of the view. And so I picked this because it's this is a story this is an article about a report that was done in the UK. And they said, this report says that a vaccinated person has a 25% chance of catching the virus. 25% chance of showing symptomatic COVID-19. It does not, the study does not mention anything about asymptomatic or natural immunity, which means that 25% is the lower bound. And yet, look at this, in that same study, they said transmission is independent of vaccination status. How can it be on one side 25%, the other side it's the same? Somebody's not doing their work. Okay. So we're talking about how do you suppress reinfection rates by not taking into account natural immunity, not taking into account natural immunity and vaccinated, because nobody checked. When they vaccinated somebody, they did not check whether the person had natural immunity. The studies I've read, the reports of studies I've read, they only check whether they have symptoms. So all these alter the actual measured rates of the infection, which means that the measured rates are unreliable. Okay, this was published in Nature Communications. It's and it says that if you had a vaccine in January, so you have to keep the seasonal environment the same for the statistical study to be correct, to be valid, to remove unknown, unidentified external factors. So you have January, one set of people were vaccinated, and then 4 months later, another group of people were vaccinated in April, and then in June, a few months later, they tested for these two blocks. So basically, these people are 4 months, 6 months into the vaccination, and these people are 1 to 2 months into the vaccination, and they compared. They found that the people who were 1 to 2 months had a certain reinfection rate from breakthroughs, and the people who had been vaccinated 4 to 5 months earlier had a different vaccination infection rate. So the people who had there were 1,911 infected people 5 months later, and there versus 760 infected people 1 month later, under the same sociological, economic, ecological, pollution, whatever environment. And that number is 2.26 increase in the reinfection rates. And they are honest enough to say, we do not know what's the long-term effectiveness. So what do we see from this? There are a lot of studies. Some say 95%, some say 99%. I'll go back to what the Wall Street Journal published, the paper that they used, and they said it's 69%, 70%, and 47% effective. So basically what this says is that if you vaccinated everybody, that's a blue population, and 5 months later, you'll have the safe population is reduced by about 50%, and the other remaining population is no longer safe. That's what it means. When you say 69% effective, it means the 30% of the population is no longer safe by your definition. And in this case, it's about 50% of the population is no longer safe by your definition. So there are issues. If you did not measure whether the person had natural immunity when they were vaccinated, are those numbers still valid? They are actually the upper bound. So the effectiveness of the vaccines is actually much less. What else should we know? This is BMJ. I believe that BMJ used to stand for British Medical Journal, but BMJ now publishes about 70 different journals. And this is one of them is BMJ investigation. They found that in a pivotal phase 3 trial, the contractor had falsified the data, unblinded patients, employed inadequately trained vaccinators, and was slow to follow up on adverse events. What does it mean by slow? It means adverse events are not recorded on a timely manner. So when you upload the data, it doesn't show adverse events. Was the whole industry based on this kind of data? I don't know. I really don't know. But this was published in a prestigious journal. And then there's this marketing gimmick. I have no idea why they call it breakthroughs. Breakthroughs means massive improvement. Wonderful, good news. That's what breakthrough means. They call a reinfection a breakthrough. I mean, what the? Okay, what about children? Robert Malone. I go back to him. I listen to what he has to say. He's been published and been talking in a lot of conferences. And he says, why are you trying to vaccinate children? In Sweden, Richard Urso, he said, not a single death from a child death in Sweden from COVID. So why are we trying to vaccinate little people whose immune system is still developing and maturing? Why are we trying to do that? And then how long does it take to do good science? The Tufts Center for Study of Drug Development estimated it takes $2.6 billion to go from a new drug to make it commercially available on a pharmacy shelf. That process takes 12 to 15 years. COVID-19 vaccine took months. So, do we know the long-term effects? There are people out there saying, yeah, it's safe long-term. Nobody has done the research. Nobody has done the research. Nobody has done follow-up studies. Recall thalidomide. Thalidomide was considered safe for decades until German and an Australian doctor reported genetic disorders. It was used as safe for decades. And then the effects was horrendous. So for people to put peer pressure on other people to get vaccinated, it is wrong because infection rates are independent of whether you're vaccinated or unvaccinated. The synthetic mRNA vaccine protection is temporary, and the long-term side effects are unknown. Okay, if you put pressure on somebody to get vaccinated and something goes wrong with that person's life, you are responsible. And this pandemic really opened our eyes to what was going on. What we are seeing is non-medical staff, administrators, politicians, people who have no real experience in treating patients are making decisions on how and where and when doctors are allowed to treat us and our children. That is clearly wrong. Even though the law says nobody can tell a doctor how they can and cannot treat a patient, what we actually see is the opposite. Politicians, administrators, public health officials are getting in on the act to tell doctors how they should treat their patients. That is wrong. Conclusion. Let's use some common sense. Problem is, if we are having all these people, the administrators, the politicians, the public health officials telling doctors how to treat patients and when to treat patients, why do we train doctors? We do not need to train doctors. Why do we even want to have doctors? We can go to City Hall and ask them, hey, look, I got this disease. Can you write out a prescription for me? Oh, yeah, you got the disease. Okay, let me write out a prescription. That's what's happening. And the mass media, the FDA and CDC, they are flipping back and forth. Why? They're not being open or honest with the American people. They don't even recognize by enforcing public and health policies that have not been effective, they are putting their own children at risk. It's shoddy science. The scientific community, I have read a lot of scientific papers in physics, in finance, in credit risk, in strategy, in statistics. There are a lot of shoddy papers out there. Peer review does not mean what you think it means. All peer review means is that there are no obvious mistakes in the paper. That's all it means. So just because a journal was peer reviewed, that doesn't mean the paper is worth anything. Note the Lancet and New England scandals, New England Journal of Medicine scandals. They had to retract their whole paper. So we ask, why are we seeing shoddy science? And then remember, there are almost 2,000 infected people before CDC took note in the US. So we are going to see the next two variants, alpha, beta, gamma, epsilon, beta. Those next two variants are already in the population. We haven't figured them. We haven't caught on. We have seen 4 variants in 18 months. So now it's almost 2 years. That means the other variants are already in the population. It takes about 2,000 people to be infected. That's what the modeling shows. My modeling shows, not the reproduction model. My modeling shows it takes about 2,000 people to be infected before the CDC takes note. And Robert Malone, he says, this is at the Global COVID Summit, he says, mutants such as the Delta variant are the direct result of vaccines. This guy invented the mRNA technology. Do you know what it means to invent a technology? It means that you understand what it takes to make something work, what it takes to not make something work, what is the environment, what are the properties of the environment required to make something work. If you're just using the mRNA technology, you don't have that big picture. You just know that 1 + 1 is 2. You do not know why 1 + 1 is 2. An inventor of a technology will know why 1 + 1 is 2. Okay? What do I say? What do I conclude from this 18 months of media bias, CDC and FDA back and forth, the lack of long-term studies, the bad data? It only sums up into a few words. It's not working. Thank you.